Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
So now we'll work on question 52 from chapter 21. Here we're given 4 structures and we're asked to name each alkene. So let's go ahead and start with part A, where we're given the following structure: CH3, CH2, CH, double bond CH, CH2, CH3. So we need to name the structure here. The first thing that we recognize is that our first thing that we need to do is name our longest carbon chain, which is 6 carbons long so we have a prefix of hex. And then we recognize that we have a double bond, so the suffix will be ene, hexene. And we can go ahead and number our carbons to minimize the location of the double bond. So in this case, it doesn't matter. It will be at position 3, no matter which direction we number in. So the name of this structure is 3-hexene. Now, if we move to part B, we're given the following structure: CH3, CH, CH double bond, CH, CH3, and then we add a CH3 substituent. So here we're going to go ahead and number our longest carbon chain, which is 5 carbons long, here. And since it's 5 carbons, our prefix will be P-N-T, pent. And then it's an alkene, so ene, pentene. And then we have a substituent here, but we need to figure out which way we're going to number, from right to left or left to right. And we can see that if we number from left to right, our double bond would be starting here at position 3. But if we number from right to left, it will be here at position 2. So that's the direction that we want to number in, to reduce that number. So we number there, and then we recognize that we have a methyl group here. So we can compile all this information. So first we write the substituents with the position. So 4-methyl. And then we write the position of the double bond, which is 2, and then the name of the chain, hexene. So the name of this molecule is 4-methyl-2-hexene. For part C, we're given this structure: CH3, CH, CH, double bond, C, double bond C, CH, CH3. And then we draw in our substituents. We have an ethyl group here. We have a methyl group here. And then we also have a methyl group here. Let's make sure this is the correct structure. So we want to first start by numbering, by identifying the longest carbon chain and naming it. So we see we can go from here to here, and we have a 6-carbon chain, so hexene because of the double bond. So we want to figure out which direction we're going to number the chain in. So we want to, the double bond will be in the same position at carbon 3, no matter which direction we number in. So since that doesn't matter, we want to look at which end has more substituents. So since the right side has the 2 substituents and the left only has 1, we'll start numbering from the right side and get 1, 2, 3, 4, 5, and 6. So this is our numbers, our numbering, and then we can see that we have a methyl at position 2 and position 5, and then we have an ethyl at position 3. So we remember that we want to include our substituents alphabetically. So ethyl comes before methyl. So we put the position of the ethyl, 3, ethyl. The position of the methyl groups, which is 2 and 5, dimethyl, di because we have 2 methyl groups. And then the position of the double bond and the name of the carbon chain, 3-hexene. So the total name is 3-ethyl, 2,5-dimethyl, 3-hexene. Now, it's important to notice here that we could actually have an alternative name, and that depends on what we define as the longest carbon chain. If we were to go from here, we start from here, and then we go up here and here, we get still a 6-carbon chain. And then our substituent here, this would be a substituent by itself. So in this case, we would still have a 6-carbon chain. The double bond would still be at position 3, but instead of having a methyl and an ethyl group on the right side, we have an isopropyl group. So our isopropyl would be at position 4 because we would be numbering in the opposite direction because of the position of the substituents. Then we would have 2-methyl, and then the 3-hexene is unchanged. So double bond still at position 3, but instead of having an ethyl and a methyl group on the right side, we just have an isopropyl group. So either of these is correct. And then the last structure that we're given is in part D is CH3, CH, double bond, C, CH2, CH3. So we add in the substituents. We have 2 methyl groups here. And then a methyl group here. So we go ahead and number our longest carbon chain, which is starting from this side to the end. And it's 6 carbons with a double bond, so it's hexene. Then we put in we number our carbons based on the position of the double bond first. And we see that if we number from right to left or left to right, the position of the double bond will be at 3 both times. So then we look at the substituents and see that we have 2 substituents on the left. So we want to start naming from that side. 1, 2, 3, 4, 5, and 6. And we have 2 methyl groups at position 2, 1 at position 4. So we're going to write 2, 2, 2, 2, 2, just 2 2s. 224 tri, because we have 3 methyl groups, and then the name of the carbon chain with the position of the double bond. So the total name is 224 trimethyl 3